Hello everyone. I have been a fan of hack and slash games since I started playing games, and I dabble in creating hack and slash character before. There are countless tutorials about making hack and slash character, but most of them focus on animation aspect of it. But depending on how data is managed in the code, it will become very tedious to add new attacks or change order, etc. This GDC talk given by Valve gave me inspiration to create a way in which it becomes very easy to edit combo data visually. As you can see, I have this data asset that already has data populated for 3 melee attacks. This is how it looks like in game. Characters do all 3 melee attacks in order, and the order is described by the filters that are assigned to those attacks. All 3 attacks are melee attacks, and if I want to add a ranged attack, I can easily do so by adding another ability and selecting the ability for that attack. Then I have to add filters for this attack to be selected. The first filter I add is select attack type, and I chose ranged attack as the attack type. Second filter I added is not has gameplay tag. Then I choose attack as the tag. This means that when attack type is ranged and character isn't doing any attack, then this attack can be selected. And here is the result. I can do melee combo like usual by pressing left mouse button, but if I hold the right mouse button and then press left mouse button, it will do the newly added ranged attack instead of doing the melee attack. You can easily add more filters that suits your needs. For example, attack type filter is a game specific filter. So I created a blueprint that extends from ability filter class and override canPass filter function and added my own code for the filter to pass. The link to GitHub project is in description below if you want to download the project. Let's break down the GDC talk to understand what is needed in detail. A simple breakdown of the GDC talk is as follows. There will be a table with list of all actions that can be done, and each action will have conditions or filters associated with that action. When the game wants to select an action, it will collect the data needed by filter and will send the data to the table. Table will go through all actions and return an action or multiple actions based on the data. There are 4 building blocks for this architecture to work. First one is the table. This contains all the abilities that can be selected, and each ability will have filters that can be used to decide whether to select the ability or not. Second block is the filters. Filters have conditions like type of the attack or number of actors in radius or player level or anything that is needed for the game. Third block is the data that is sent to the table, and fourth block will be the algorithm that decides which action is best suited based on the given data. Table will be a data asset in the Unreal Engine. I want to be able to add and create my own filters based on my game needs. Since filters can be created based on the game, the data needed for those filters will also be dependent on the needs of the game. The algorithm needed to select suitable actions is also heavily dependent on the game. So I will make my filters, data, and algorithm to be all U objects so that new ones can be created based on the needs. With this understanding, we can start implementing it in Engine. I started by creating a strat called ability select data. This represents a single row in our table. As discussed earlier, each row will have a gameplay ability and an array of filters that associate to select that ability. I added ability spec handle variable because I want to store the handle that gets returned when giving ability to the character, and use the handle to activate the ability instead of using activate ability by class. Activate ability by class works by looping through all the abilities that the character has to find the ability of the same class and then use the ability spec handle of that ability to activate the ability. By saving and using the handle, all of this can be avoided. The filters U property has to be marked as instanced because that will create a new object every time, which will let us edit the values for each of them separately instead of creating different blueprints for just different values. For example, here is how non-instanced U property looks like compared to instanced U property. I can add multiple filters and edit their values separately if it is instanced, but if it is not instanced, then I can just set the class and can't do anything else. Next, I created ability filter that extends from U object and added a blueprint native event called canPass filter, which takes filter data as input and returns true or false. I also added an integer called passing score that can be changed so that I can give high score for filters that I think are more important. Then I created a ability filter data class that extends from UObject and added a blueprint native event called collect data. This function will take care of collecting all the data needed for filters and saving that data in variables. Right now, I just save the character, but will add more later as I add more filters. Ability selector class also extends from UObject and has try get abilities function. This function contains all the logic on how I want to select an ability, and it will return the abilities that are selected. More on this later when I create different logics that I think are most commonly used. Now that we have all the building blocks, I created ability data that extends from UDataAsset and added two functions, one that gives all the abilities to the character and one that tries to get the abilities. I also added a uProperty called ability filtered data that represents the type of the filtered data that is needed, and ability selector, which is what algorithm to use to select the abilities, and an array of abilities select data so that I can add as many abilities to the table as I want. Give all abilities to character, will get ability component from the character and loop through all the abilities and give them to the character. Try get abilities function will call collect data on filtered data to collect the data needed, and then call try get abilities from ability selector to use the selected algorithm to get the filtered abilities. Compile and restart the editor, and I can create a data asset based on the ability data. All the building blocks are in place, and right now I just have to create the most common used filters and ability selector algorithms and filter data to get this to work. Since we already have character, I will start with the easiest filters. Is character falling or not falling, which will pass if the character is falling or not. I will create a C++ class that extends from ability filter and override can pass filter function. In the implementation, I will just return if falling or not falling that we can get from character movement component. I just added one attack to my table without any filters. I can do the attack, but I can also do the attack even if I am jumping. So I will add a filter that says if character is not jumping, so that I can only attack when character is not jumping. Next easiest filter to implement is to check if the character has certain gameplay tags or not. For this, I need to be able to access gameplay ability component of the character, which means the plugin needs to have access to gameplay abilities plugin. To do this, I open the plugins menu and select my plugin and click edit. Then I add gameplay abilities plugin under dependencies. Then in the build.cs of plugin, I add gameplay tag and gameplay abilities as a private dependency modules. Now that I have access to gameplay abilities plugin, I created two classes that extend from ability filter, and inside can pass filter function, I get the ability system component from the character and return if the ability component has all matching gameplay tags or not. With this new filter, I can add chain attacks so that one attack happens after another. All my attack abilities add a gameplay tag to character. So for first attack, I add filter that says if character doesn't have any attack tag on it, select it. And for the next attack, I add filter saying if the character has the tag that says he is doing the first attack, then select the second attack. With a simple change like this, I now have combo attack working with two attacks. Next filter will be getting actors in the radius around the character. This is little complex to implement, and here is where filter data collector comes into play. If there are 50 attacks that has this filter on them, I don't want to do spear trace or search through actors for 50 times, when I can do it once and give access to the stored data to all filters through the filter data collector. Unreal does not allow nested containers as uProperties that can be accessed in blueprints, so I had to break all of them down into smaller structures. First struct I created is an actors in radius struct that has radius and array of all the actors that are in that radius. Second struct is actors in radii. This is just an array of actors in different radii. So this contains all the actors in every radius that all filters needs. And in ability filter data, I added a map of actor class to actors and radii struct. You can see how this container will work. I can have filters like, are there any actors of type item in radius of 100 and can get response. Or if there is a special attack that I want to do if there are two AI characters in radius of 200 around my character, then I can just add the filter and set the class to AI character and radius to 200. Inside collect data function in ability filter data, before searching for actors, I want to know if there are any actors in radius filter attached to any of the attacks. And if the attacks have actors in radius filter, then I want to get max radius for all the filters and also reset any data that was there from previous run of collecting data. To get the actors, I first loop through all the abilities and filters attached to those abilities and cast the filters to actors in radius filter. If it is actors in radius filter, then I will save the radius if it is larger than the previous radius and check if the map has the data for actor type and add if it doesn't. Then check if actors in radius has the data for the radius from the previous run. If it has, clear the data or else create an object and save it. If there are actors in radii filter, then I will do a sweep test with sphere shape with max radius and get all the actors in max radius and loop through all the hit results and sort the data based on actor class and radius into the actors in radii map that can be used by all the filters. I made actors in radius filter as an abstract class so that any filter that needs data for actors in radius will inherit from this class. For example, I added two filters, no actors in radius and number of actors in radius. For no actors in radius, I get the array of actors of type in the radius and see if the array length is 0. As for number of actors in radius, it is same, but I check if array length is greater than or equal to the number specified. With actors in radius filter in place, I added the third attack to my combo by adding new attack ability to the table and setting it to perform third attack after the second attack by adding has gameplay tag filter. I can now do 3 attacks as a combo one after another. But I want the third attack to only happen if there are at least 2 actors in the radius. So I added number of actors in radius filter and set the type to actor and radius to 100 and number to 2. Now the character doesn't do third attack and stops at the second attack. And if I move to a place that has 2 actors around the character and do the combo, the character does the third attack. This is a very versatile way of implementing filters, because if in future I want to know if there are any actors in front of me in a cone of an angle, then I can use the same actors and radius filter to loop through all the actors and check their angles from my forward vector and filter them and return true or false based on the angle. Now all that is left is to create algorithms that will be used to select the abilities. 2 examples that I can think of would be to go through all the abilities and return the ability with highest passing score. Or instead of checking all the abilities, return the first ability that satisfies all the filters. I made an abstract class called Ability Selector that has a blueprint native event called tryGetAbilities, which returns an array of ability select data. I return ability select data instead of just abilities because it contains both ability handle and all the filters. So if ability needs some data like the actors in the radius so that the ability can play some docking animations with the enemies, then using the filter, I can get data from the filter data. I made a class extending from ability selector called abilities with highest score and override the tryGetAbilities function. For highest passing score, I created an internal struct that saves abilities and score that ability has. Then, inside the function, I loop through all the abilities and their filters and call canFilter function on the filters with selected data. If any filter passes, I add the score to the total score, and if filter fails, then I continue on to the next ability, because I don't want abilities that fails even one filter. Once all the scores are calculated, I filter the results to only contain the abilities with highest score and then return those abilities. And now, I can set both filter data and selector algorithm here in the data asset. I want to add ranged and melee attacks to the game. That means I need to create a filter that can detect if my game character is in ranged or melee mode. I created an enum called attack mode that has two values, melee and ranged. Then in character, when I press right mouse button, I set the attack mode to ranged, and when I release it, I set it back to melee. Then I created a blueprint that extends from ability filter data and created a variable called attack mode. And I override collect data function and call parent collect data. I get the character and cast it to the game character and get the attack mode of the character and save it. Attack mode can be accessed from character, so there is no need to save it here. But imagine in some other situation where the functionality is very heavy to call, or if it is something like a random number, then we don't want to call or calculate it in every filter. So caching the data in data filter saves a lot of performance. I couldn't come up with a better example, and I want to show how the game specific data can be cached. You can also go through all the filters and only calculate and cache data if there are filters that needs it, like how I did with actors and radius filter. I created another blueprint that extends from ability filter and named it character attack mode. Then I created a variable called character attack mode and override canpass filter function. Then cast the data to the newly created filter data class and get the attack mode from the data and return true or false based on if the character is in the attack mode or not. When I open my combo data asset, now I can set the filter data to newly created filter data and add character attack mode filter to all my attacks. Now, adding a new ranged attack is just a matter of adding another attack and giving it the filters needed. With a simple change like that, now the character can do ranged attack. I want to show how to create different selector algorithms. A simple selector can be selecting a random ability from the pool. I created another blueprint that extends from ability selector and named it random ability and override try get ability function. Then I get number of abilities and generate a random number and return the abilities of random index, ignoring all the filters. Inside the data asset, I set the selector algorithm to random ability. Now you can see when I press attack, character does random attack each time when I press the attack. I actually had to press attack a lot of times for it to randomize. As they say, random works in mysterious ways. Project isn't limited to one data asset. I can have one ability set for character that contains everything the character can do, and I can have data asset for each weapon with attacks that the weapon can do. So when character equips a weapon, it will do the attacks that particular weapon can do. I can also have items like keys that has ability to open the doors. And I can do all this without even changing any code on my character. This style of coding is called decoupling, where changes to one system shouldn't require changes to the other systems. Decoupling helps with keeping technical debt of the project to minimum and can make adding new features or changing existing features easy. I will add clear all abilities function that will clear all the abilities that are given so that when I unequip a weapon, all the abilities that the weapon has will be cleared. That is all I have for today. Don't forget to check the code in GitHub. Thanks for watching.